G'day guys, welcome back to MiracleMAX. Today's task is having a look at a rainwater pump that's just stopped working. I'm not sure if it's a mechanical fault or an electrical fault, so let's get into it. Even though this pump's been undercover, you can see that it's quite crusty. Even the base of it itself is all rusted out. Not that that's an indication of why it wouldn't work, but just gives you a rough idea of the condition of it. I don't know how old the thing is. It's a Kasa brand, never heard of it. Model F800, one of those cheapy type brands I guess. I'm not sure if they're a Chinese pump or whatever, but either way this thing's not working at the moment. So, is it an electrical fault or a mechanical fault? How can we diagnose between the two? We can see that the pump itself has power. It's got the little green light illuminated there. It's also got a failure light on. But when we press the restart button, you can see that the pump comes on, but nobody's home, of course. So what's happening inside? Why is it not firing up the motor itself? As you can see, power comes into the control box there. Then it slides down into the motor itself, but it also goes through another control box. Perhaps there's relays inside, I'm not sure at this point. But if we have a look at this connector here, it looks kind of vaguely familiar, and I'll explain why. If you have anything to do with computers, you'll probably notice that this fella looks very, very familiar. So that connector there is the same as our main power supply that goes into our computer. So we can just bypass all this altogether and find out if this control box here, the one on top, is going to work. Then that will tell us if the motor itself is faulty or this control box in here is faulty. So let's just bypass everything and see what happens. Obviously with a water pump you don't want to run them while they're dry, but just for testing purposes we're just going to briefly run power to it and see what happens. Okay. So that now tells us that the pump itself here, or the motor, the electric motor, is okay. The wiring etc. that comes into this box and then goes into our pump etc. must be okay. So we're looking back up this direction toward our control box. If we zoom in we can see how this controller works. On the top side here is our power in, and this is our power out to our motor. So if I test it, I've just found something interesting, so I'll just zoom out a little bit. Remember the top section is our power in from the power point. This one here is going to our motor. Let's just have a look and see what the results are when I do some testing. When you initially put power to it, it's interesting, the power failure light clicks off and on like a relay clicking in and out. If we have a look at the top section here, have a look at the multimeter here, and we've got what we would expect here in Australia, 240 volts. But if we go to the output side of things, we're only getting 112 volts. Even if I press my power up button, I'm only getting 110 volts. Now there's no way that that's going to kick over the motor itself. So we have to look further. Is there a voltage drop perhaps? That's something to consider. Just as a reminder guys, we are dealing with high voltage here. So as you can see we're looking at 240 odd volts AC. This is enough to give you a nasty bite, so whatever you do take care. If you're testing with the components still hooked up, make sure that you're extra safe. It's a good idea to use leads etc, test leads that are category 3 to up to 1000 volts that is, and that will protect you, but if at all possible, do most of your testing without power applied. I've pulled the control board off the plunger assembly over here. You can see that this has a plunger here, and in the back of the control board you'll see a hole that fits into. Usually that's operating a reed switch. Water pressure builds up in this area, forces a magnet out this direction, which engages the reed switch in here and turns the pump off once it's built up pressure, of course, and we're not seeing that at the moment. It's important when you're working with electrical appliances, especially high voltage stuff, that you have the plug visibly in front of you, because accidentally you may leave it plugged in and turned on, forget about it, and then you can get a nasty shock. So you want to make sure that you have got it disconnected and you're safe. The controller's off, as I mentioned. This is the little reed valve that I was talking about. This is the plunger here that goes in through that storage area before it goes out, and that fits in the back here, and that brings the reed valve open and shut. It's easy enough to show you how that works. I've got it connected onto ohms at the moment, as you can see, and I'm across the reed valve here. We can see we've got really high resistance. That's because it's going through the circuitry. But if we flip it over and stick that plunger into the back of it, have a look at what the multimeter says now. It's 0.3 of an ohm. If we pull it out again, you can see that it goes back. So we know that that reed valve is shutting correctly. So it's not a reed valve issue with this particular one. I've just noticed on the back of the controller there's a second reed switch, and that fits into this little slot here. And there's a plunger inside here. When the water comes through, it will block that off. It's like a one-way valve, I guess. And that has a little magnet that goes off and on up here. So what I've done is I've held this against here like this with some leads on, with my multimeter leads on there, and that reed switch is operating correctly when I move that plunger inside there. So all those systems are working okay, the reed switches, so they should cut in and cut out. So I've still got to investigate further as to why this is not working. So I've been doing a fair bit of testing off camera. I've checked all my resistors, diodes, etc. And have had no trouble with those whatsoever. The only thing that I have even checked the IC. It's a bit difficult to check on board. I don't have the proper facilities to check that particular one. So I've identified the IC as a HEF 4093B, which is a quad 2 input NAND Schmidt trigger. Basically, we have NAND gates over here, 1, 2, 3, 4 of them, and I have found a couple that are a little bit strange, but as I said, I'm testing it on board, so it's a little bit difficult to confirm that. I don't know about you guys, but I get really annoyed and frustrated when I can't figure out, or I can't pinpoint the reason behind a fault. I can see the fault, but if I can't find the actual reason for it, it really annoys the hell out of me. Don't know if you're the same. But remember I said to you that I couldn't really test this NAND gate IC on board, of course, you know, in the little control box. So look, I laid awake the other night and started thinking about it and thought, nah, damn it, I'll pull it off, see if I can figure out if I'm heading in the right direction or just barking up the wrong tree. So look, I'll be honest with you, I haven't had too much to do with IC testing before, so it's been a little bit of a learning curve for me. But I have, as I've shown you before, I've shown you the data sheet, so you know what it's on about. But I'll just give you a little bit of information, as I've found out myself, how it actually works, how it physically works. So over here we have our the data sheet, and it is a NAND gate system. So we have an input here, and an output is number 3. So what does it actually mean? So we need to look at what's called a truth table. So the truth table might be a little bit hard to understand at times. So what I'll do is I'll explain it as best as I can. So if we were to put a ground here and a ground here, we would end up with 5 volts at this point. If we were to put a ground here but 5 volts there, we would still have 5 volts there. If we were to put 5 volts here and a ground here, we would still have 5 volts. The only time that this will turn to ground or 0 volts or low volts, whatever that may be, is if we put 5 volts here and 5 volts there. I'd like to prove that because I've put that little chip onto a breadboard and I've got a little LED here, as you can see. Now I'm not sure how good that's going to show up, and that's why I apologise for the lighting. You're probably not going to get the right angle. What's that like? Actually, that's not too bad, is it? If you have a look at our pin out here, our inputs are numbered pin 1, pin 2 and pin 3 as our output. So I'll just show you how that one works. I've had a few technical difficulties trying to get the LED to light. It's mainly because one of the pins, the main 5-volt pin to the IC, is playing up a little bit. I damaged it when I removed it, so that's my fault. If we zoom in just a fraction, just to give you an idea of what I'm up against. So remember when we talked about the high and low side of things? Now I've got 5 volts at both of these wires here, and if I just put it on pin 1, we can see that it stays. It may cut down a fraction, let's have a look. No, it stays there, but if I put it on pin 2 as well, there we go, it goes out. So if we have pin 1 and pin 2 with voltage going to it, you can see that it turns off. Now I've done that to all of them. The only difference that I have found, so in other words what I've done is I've tested all of these, so I've put 5 volts at 1 and 2 and checked, or 3 comes off going to my LED. Then I'll put power to 5 and 6 and my LED at 4, and I think I did it to, which was next, I think it's the 8 and 9 one that's a bit dodgy. I'll show you that. So 8 and 9 are our inputs, so I need to connect this one here to pin number 10 is my output. So let's count back on those. So we have, what's that, pin 8, pin 8, pin 9, pin 10. So in actual fact, shouldn't that be high already? Shouldn't I have an LED lighting here, which I don't have? I've just got my finger on the IC to put some pressure on that 5-volt input pin. It's a bit dodgy, but even in this case it's still proving that this chip is faulty. Our output is number, what's that, 11? So that's this one here, and that's going off to my LED. And 12 and 13 are my inputs. And we can see that I've put 5 volts to both sides, so they're both high. This should be pulled low. As you can see, the light is still on, and it makes no difference whether we put the power to it or not. We're not seeing a complete shut off of the LED by applying high voltage, or in our case 5 volts, to our input pins of the NAND gate, and our output pin is still supplying voltage to our LED. Therefore that gives me confidence to say without a doubt that this IC is faulty. One of the hardest decisions you've got to make is to know when to stop, or to say, I have checked it at a component level and it's not repairable. And this is what's happened in this particular case. I was able to buy this component, which includes our total circuit board, the safety side of things, the safety valve in here, the diaphragm, safety one-way valves both here and here. I paid about $30 for the thing, delivered in 2 days, free delivery as well, mind you. Unfortunately here in Australia I couldn't get that chip, that IC. It's a through-hole one. The only ones that were available were surface mount devices. So I made a decision based on that. This thing needs to be up and running. 30-something bucks, 2 days delivery. It was a bit of a no-brainer. I would have liked to do it at component level, but unfortunately I weighed up the pros and cons, and this is the best decision to be made, I believe. So let's pop it on and see if we can get it up and running. We just take a couple of minutes to have a look at the comparison between the old unit and the new unit. You can clearly see that all these components are through-hole components. There's no surface mount devices or SMDs there, whereas on our new one, of course, they're pretty much all SMDs. The setup is pretty much the same. We've got our reed valves, both one here and up the top there, in the same location on the back that there is on this one. Also, I did notice too that they have, which there should have been originally, I did mention that there was a varistor up the top here, or there's capability for a varistor up the top. And in the later one, obviously there must have been an issue because they've included another varistor. We have a clear relay cap, which is nice to see. You can check for pitting and all sorts of stuff, which you can't do with an enclosed one. Basically the construction is the same, apart from the fact that they've gone to surface mount devices, etc. I do notice that this transistor is missing too, so whether they've updated that into something else I'm not quite sure. But yeah, obviously this is an updated model. Perhaps they had a few issues with this earlier one, maybe that's the reason this one failed. The only thing I need to do now, which I've already done in this particular case, is change over the original wiring. I just need to do it, change over this wiring to here, and then she's ready to go back onto the actual accumulator and electric motor. Hopefully we can get this thing up and running, and well, more importantly, hopefully we can get some rain so that we can drag the water up from the tanks. I've now changed over my wiring from the old unit to the new unit, but while I was there I thought I might as well tidy up what I thought was one hell of a dodgy looking thing. This was the wiring that went into the power side of things, so here. But check it out, like instead of replacing the wiring back here as I've done now, they made up this farty little extension cord. Check it, check it, check it. It's just disgraceful. And of course, you know, dirt and grit and grime gets in there, and bad connections and all sorts of stuff. For crying out loud, if you're going to make the effort to... someone's just put an end on something, obviously that's a sealed unit there, but they've made up this tiny little extension cord, which then was hanging. It didn't even make the correct distance to the pump itself. It was sort of hanging in a bit of a loop like this, so it was a bit of a tripping hazard as well. So I keep a lot of old computer cables and anything like that, any AC cables, and all I did was cut the end off of one of these really long computer cables, just cut the male fitting that goes into the power supply, just cut that one off, and then take that into my main power feed into the control box there, which, you know, it's an obvious thing, isn't it? If you're going to make up a dodgy little thing like that, why not just put in 5 seconds more effort and do it neat and tidy, so you won't have any weather issues, no corrosion and stuff like that. So if you're going to do a job, do it properly, guys. I've now got the control box with all its outlets attached. It's fitted nicely. I guess the thing is, does it work? Moment of truth, guys. I'll switch it on, let's see what happens. Of course, just a reminder, when you're working with a water pump, you shouldn't run it without water in it. At this point in time, I'm just going to flick it on and off very, very quickly. That should be fine, but never run a water pump without water in it. Gonna work? Let's have a look. I turned it off, by the way. Okay, so it's kicking in all right. I've now got to put it back into place and make sure that it actually physically pumps water and it cuts it out under pressure. And then of course when that pressure drops down, it should kick back in again. And that would ensure that all the control systems in our little box here are working properly. Before you get excited and turn on the pump once you've connected it and let it run and wonder why it won't work, don't forget you really need to prime these pumps. You can pull out one of these bungs here and just fill up the accumulator with water, and that will help the pump to then draw up the water from the rainwater source, which in this particular case is some big rainwater tanks that are you know, quite a few metres away. I'd say probably, let's guess 20-30 metres away, and then they drop down one level, so it's got a fair bit of water to pull up. So it's important to prime it. So once you've primed your pump, it's ready to go. You turn on your tap, your rainwater tap in this case, leave it open, and that will pull all the air through, or the air will be forced through by the water pressure being pulled up. So let's see if we can get this up and running. Look at that, eh? Okay, cool. That showed us several things. Firstly, that we got all the air out of the line. We could see it spitting out over here out of the tap. And once we got rid of all that air, we could turn off the tap, and then we could hear the pump complete the circuit, and eventually it turned off, which is really nice. So in theory, if I turn this back on, pump should cut back in. Once it gains pressure again, it should cut out very shortly. And there we go, job's done. Excellent. That's another one off the list, guys. I'm glad it's finished. It's going to be about 42 degrees here today, so I wanted to get that thing over and done with. I'll be honest with you, I was a little disappointed I couldn't fix it at the component level, but sometimes it depends on cost, availability and the time factor as well. I believe that that was the right call in this case. As you could see, the circuit boards were modified, so perhaps they had problems with these things. Well, I'm going to head inside to where the air conditioner's on because it's pretty damn stinking hot out here. You know the drill, guys. If you enjoyed this video and haven't already, please subscribe to the channel, give it a like, feel free to comment down below. Don't forget about that notification bell. You don't want to miss out on any future videos. So until next time, guys, this is MiracleMAX signing off. I'll catch you later.